Hi everyone. So today we are going to continue with the last class. Last video we saw about fundamental theorem of arithmetic, right? So we did a few problems, we saw how to do, and also I gave few problems for you to work out. So now we are going to continue. So I'll give you the answers for those. So the numbers, the sums which was circled. So those problems I told you to do. So we'll check the answers. Okay, so for express each number as product of prime factors. For 156, it is 2 square into 3 into 13. Then 5005 is 5 into 7 into 11 into 13. Then second sum, third subdivision was given as homework. That is, you should find HCF and LCM, and also we should verify the property that HCF into LCM equal to product of two numbers. So here the two numbers are 336 and 54. Here by mistake it is given 52. But the sum is done with 54 only. So 336, the prime factorization is 2 power 4 into 3 into 7. 54, the prime factorization is 2 into 3 power 3. Okay, so now we'll find HCF. HCF I already told you which are the numbers common. So here 2 is common and 1 3 is also common. So HCF will be 2 into 3, 6. Okay, now LCM, I already told you, will write all the prime factors, and those which are common, that will be written only once. Okay, so the other way of writing I'll tell you. So 336 is 2 power 4, 3, 7, and 54 is 2 into 3 power 3. Now you see in 336 it is 2 power 4 and in 54 it is only 2. Now how to write LCM is, so you take which the maximum number of 2. So which has the maximum number of 2? So 2 power 4. So you write 2 power 4. Then 336 you have 3, and in 54 we have 3 power 3. So which is maximum? 3 power 3. So you write 3 power 3 in LCM, then 7. So LCM will be equal to 2 power 4 into 3 power 3 into 7, which is 3024. Okay, the product of the two numbers is 336 into 54 is 18,144, and HCF into LCM also we get the same answer. Hence we have verified the property that HCF into LCM equal to product of the two numbers. Then third sum, second and third subdivision were given homework. So second sum 17, 23, 29. So we have to find HCF and LCM. So 17 is written 1 into 17, 23, 1 into 23, 20. They are all prime numbers. Can you see that? They are all prime numbers. Actually, this 1 into 17, 1 into 23, 1 into 29 are not prime factorization. Actually, they are not prime factorization because 1 is not a prime number. Do you remember? 1 is neither prime nor composite. So these are not prime factorization, but to make you understand what is HCF of these three numbers. Okay, HCF of 17, 23, 29, you can see that they don't have anything common, but you have 1. So HCF of these three number is 1. Okay, so to make you understand how HCF is 1, that's why we have written this factorization. Okay, now LCM will be, so we'll write all the prime factors. So 17 into 23 into 29, you get 11,339. Third subdivision, 8, 9 and 25. So the prime factorization of 8 is 2 cube. Prime factorization of 9 is 3 square. Prime factorization of 25 is 5 square. So here also you can see nothing is in common. So what you will write HCF? HCF will be 1. LCM will be all the prime factors. So you will have to multiply 8 into 9 into 25, which is 1800. That is 1800. Okay, now we'll move on to the next three questions. Check whether 6 power 9 can end with the digit 0 for any natural number n. Okay, so now that is 6 power n for any natural number n. 6 power 1 is what? 6. 6 power 2 is 36. Then 6 power 3, 6 power 4, 6 power 5, 6 power 6. So if I take any power of 6, okay, the question is, will those numbers, any of those numbers, will it end with 0? That is the question. Okay, so now you can see the prime factorization of 6 power n. So we will see the prime factorization of 6 power n. So 6, the prime factorization is 2 into 3. Okay, now just think, for a number to end with 0, for example 50 or 120 or 300. So for a number to end with 0, you can see that in their prime factorization they will be 2 and 5. That is 2 into 5 will be 10. Am I correct? 2 into 5 will be 10. So 10 will be in the factorization. So to get 0 at the end of the number, so in its prime factorization there should be 2 and 5. If you have 2 and 5, then only when I multiply it will become 10. So the number will end with a 0. Okay, so here 6 power n, any power of 6 you will have the prime factorization only 2 and 3. So you don't have 5. Since you don't have 5, then this number will not end with 0. So 6 power n is 2 into 3 power n. The prime factorization of 6 power n does not contain 5. Therefore, there is no natural number n for which 6 power n ends with the digit 0. Okay, is that clear? Now sixth question. Sixth question, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So to prove composite number, I should prove that they have more factors. Prime number means what? They have only 2 factors, the number 1 and the number itself. Okay, composite number, I have to prove that they have other than those factors also. Okay, so we'll prove that. So first one, we take 7 into 11 into 13 plus 13. So you can see here 7 into 11 into 13 is one term. Okay, then plus 13 is another term. From these two terms, 13 is common, so we take that out. So when 13 is taken out, so what do you have inside the bracket? You have 7 into 11 plus 1. Okay, if you want, you can simplify further and you can just stop here and say that here you have 13 into some number. Therefore, this number will be divisible by 13. Therefore, it is a composite number. So it has another factor also, that's why. Okay, the next subdivision, 7 into 6 into 5 into 4 into 3 into 2 into 1 is one term. Then plus 5 is another term. Okay, so now in both the terms we have 5 common. So take 5 out and then you write the remaining. Okay, and you can say that this is divisible by 5, therefore it is a composite number. Okay, if you want, you can simplify further also and you can say it is a composite number. Okay, now question number 7. Okay, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay, so did you understand the story? So two persons, Sonia and Ravi, are starting at the same point in a circular path. They go in the same direction, but Sonia takes 18 minutes to complete one round. Ravi takes 12 minutes to complete one round. Okay, they take different time. The time taken is different. Okay, the question is when they will meet. Okay, at what? After how many minutes they will meet. Okay, so now first Sonia takes 18 minutes for the first round. Then second round, how many minutes it will take? Plus 18 minutes, so 36 minutes. Then again third round, how long it will take? 54 minutes. So here you can see that the time taken are multiples of 18 for Sonia. Now Ravi, first round he takes 12 minutes. So second round he'll take 24 minutes, then third round he'll take 36 minutes, fourth round he'll take 48 minutes. So for him the time taken for next rounds will be multiples of 12. Okay, so Sonia, her time taken will be in multiples of 18 and Ravi, his time taken will be multiples of 12. Okay, so at one point they will meet. Okay, so when the time coincides, okay, the same time. So here we have to find the common multiple of 12 and 18. So common multiple of, there are many common multiples. Actually they will meet. Again, but first when it will meet. So that will be least common multiple. So I should find the LCM of 12 and 18 to find after how many minutes they will meet. Okay, so we have to find LCM of 12 and 18. So 12 prime factorization will find 2 6s are 12, 2 3s are 6 and 3 1s are 3. 18, 2 9s are 18, 2 9s are 18, 3 3s are 9 and 3 1s are 3. Okay, so we'll write the prime factorization and we will write all the prime factors. Okay, and we get 4 into 9, 36. So they will meet after 36 minutes. Okay, this exercise is over. So now next video will start the next concept. Thank you.